Quick shout out to Maggie, Jory, and Ryan. This video is for you guys. This is the last lesson we're doing right before break, and then we will have our test the Thursday, Friday when we get back. So, quick review. I'm only going to talk about this real quick. We're not going to do the solving right away. But what is the difference between big arc and little arc? Big arc, you get the one principal value, and for little arc, it's not a function. Remember, big arc is a function, a value from a function, and little arc is all the general solutions. I will do these problems at the end, but if you guys want to try them on your own just to review, that's fine as well. And then you can turn the video off and you don't have to watch me do those if you want to just try to review them. Alright, so solving trig functions is similar. We use the 2 pi k, but actually we don't always use 2 pi k. We have to use the period. So actually I'm going to write that. We use the period to find the infinitely many solutions now. Back when we were doing the other ones, the period was always 2 pi because we didn't do any shifts or anything. Now we're going to work with functions that the period has changed. So we're going to have to solve them and do each thing. So for each of the following functions, we have to find the given function value. That's just plugging in to your calculator. Then find the general values of the angle for the given values of f of x. Okay. Make sure your mode is in radian. Round all answers to the nearest 10,000th. So let's do the first one together. F of x is equal to sine of x. I'm going to take my calculator. Well, first of all, there's no shift, so the period goes from 0 to 2 pi because there's no frequency or anything. So that's going to be our window. Our node is at 0. Our max and min, or our crest and trough, if you want to call it, should be at 1 and -1. Because remember, original sine, that's what the starting values are. So that's just a standard sine curve. So let's graph that. We have y is equal to sine of x. And make sure a couple things. Make sure you're in radian mode. We are. I am at least. And then I'm just going to graph to see what, well, that didn't really work out because I'm in a weird mode right now. So here's what you can do. Let's set our window to what we know. We know our x min, we'll say, is 0. We want to graph one cycle. X max is 2 pi. So I want to look at one period of this. The scale could be 1, it doesn't matter. Y min is -1, and y max is 1. So if we graph this, we should see just one sine curve. And sure enough, we have a perfect sine curve here. Now, we're going to use that later, but before we do that, we want to find out the value when f of x, or when x is 3. So you can either use your table, or we can use function notation. I'm going to use function notation right now. Do you guys remember to do vars, y vars, and then hit enter on function, and then we have y1. I want to know what y1 is when x is 3. When you hit enter, you get that the trig function is 0.1411. So that's my final answer for this one, 0.1411. And that's either from the table, or you could also look at the table if you wanted to. Now, this is the important part. This is saying that we don't know x, we know that y is equal to 0.5. We want to know what x is, so it's like the opposite. So let's go back to our graph. And instead of putting 0 in, remember when we put 0 in to find our zeros? We want to know what happens when y is 0.5. So let's graph this. And this is why it's important to fix the window to look at just one cycle. There's my graphs. Oh, I have it simultaneously graphing, which kind of looks cool actually. Alright, so now normally, remember when we went and did this before, and you could do it this way too, but when we did this before, we would do inverse sine, which is what this answer gives us, plus 2 pi k, and then we'd find the other spot on the circle, which happens to be over here, and also do plus 2 pi k. Because what happens is, I'm going to just zoom out real quick. Look what happens. It hits so many times, it goes on for infinity. But like I said, we want to just zoom in on the one curve. So I'm going to do that again. I'm only doing this one time a lot, just so you guys know what I'm talking about here. Okay, so anyway, there's my cycle again. I need to find these intersection points. And remember, when you find these, you're getting an angle in radians. Because these are weird angles, you do not need to divide by pi, okay? Do not divide by pi. Just leave it as the decimal. So second trace 5 is intersect. I'll hit up to get onto the 0.5 line, and I'll go all the way over to the original starting point. Okay? Now, hit enter a couple times. And I get that the first intersection is at 0.524, or sorry, 36 radians. 0.5236 radians. So, we have x is equal to 0.5236 plus the period is 2 pi k. So 2 pi k. I need to find the other one. It's also second trace 5. We have to move over to the other one, and then you can get the final answer. Hit enter a couple times. 1, 2, 3, and it's 2.61799. So that means it's 2.6180. 2.6180. So plus 2 pi k. Now remember, it will not always be 2 pi k though. Alright? So we have our solutions. We're good. We found the period. We found our solutions. Those are our two solutions. Alright, next problem. Before you do anything, well, I guess you can do part A whenever you want, because it has nothing to do with part B. So if you want to do part A and just get that done with, you can. Let's type in this function. So we have 2 cosine of 4, 2 cosine of 4 parentheses x minus parentheses pi over 2 parentheses parentheses parentheses. So we closed all that out, and then plus 1 I believe is the problem. Let me just double check that. X minus 2 plus 1. Yeah, so get that in there. The second line doesn't matter. I'm not even gonna graph this yet. I'm gonna hit second mode to get out of here. Now, if you've already had this up, you can hit second enter to bring your last thing up. And I want to evaluate this function at 4.3. So I'm going to go, instead of 3, I'm going to turn this to a 4.3. And I hit enter. And I get 0.8426. So the answer to that is 0.8426. And that's all you have to do for part 1. So 0.8426. Now, the second part is where you have to do a little bit of work. It's a cosine curve. So normally the cosine curve goes from 0 to 2 pi. But we want to find the actual period. Remember, the period is when you divide the frequency. So the period will be from 0 to pi over 2. This is your frequency, or your period. This is important to know. The period is from 0 to pi over 2, so it's pi over 2 radians. We need to know that when we find our final answer. Okay? Now, let's do the shift though. So let's add pi over 2 to both sides. So I get pi over 2 x, and then it goes to, what is that, pi. And then we also have to figure out where the node is. The node's at 1. The max value, or the amp is 2, so the crest is 3, the trough is 1 minus 2, negative 1. So we go 3 comma negative 1 for the max and min values. The reason why I do that is I'm going to graph one cycle. Again, you don't have to graph one cycle, but I would like you to get the one cycle that's in this range here. So I'm going to put all this information in. My period's pi over 2. My window will go from pi over 2 to pi. And if you do this correctly, you will see one full cycle in here perfectly. The y min is negative 1, the y max is 3. I just entered in from my inequality range, my lowest point, my highest point. Let's graph it and see what happens. There, remember, it's cosine, so it'll start out. Oh, and ignore that line. That was from the last problem. So it goes down, and then that is a perfect cosine cycle right there. So I want to know what the values are when y is equal to negative 0.3. So remember, this is y now. I don't want that to be x. So I put negative 0.3 in for y, negative 0.3, and I graph. And there's the line I care about. So you guys should clearly see I want those two intersection points. And then, let's get those. I'm going to hit down so I'm on the line that I care about. Let's get the first one first. And we get 2.1404. 2.1404. So I get 2.1404. So in a way we're doing inverse cosine to solve here, but this is another way to do it using the graph. Plus, now here's where the difference is. It's not 2 pi, because this graph repeats itself every pi over 2. So it's pi over 2k. Okay, that's where the period comes in again. That's why you need to find out what the period is. And let's find out our other answer. Move it over. Enter, enter, enter. And you get 2.57199, so that's 2.5720. 2.5720 radians. Remember, the pi is already included in these. You do not need to divide by pi for these because they're weird decimals. So you can leave the pi in there and pi over 2k. So these are our two solutions for B. This is our solution for A. But it's important to do this work ahead of time to make life a lot easier for you. Alright, so let's do a couple more. We only have 2 more to go. I don't know where we are time-wise, but I'm going to kind of go through this pretty quickly now. We can do that later. So, I am looking at a period, well, it's a sine curve, which normally goes through 0 to 2 pi. Okay, so if we multiply by 15 over pi, that's what you do when you have a pi over 15. Multiply everything by 15 over pi to get rid of that pi over 15. And we get that 0, x plus 4, 30. So again, 30 is now the period. And then I'm going to get the domain here. I have negative 4, x, 26. So that's going to be my window. The node is at negative 1. So plus 9 is the max is at 8, or the crest. The min is at negative 10. So these should be my values I enter to graph a cycle. So let's type this in the way it is. I have 9 sine of pi over 15. Make sure you type this incorrectly. The pi over 15 has to be in its own parentheses, because it's that, and then it's x plus 4. Close that out, and then close it again. Now we're out of the sign. And then, what was it, minus 1? Minus 1. Okay. So, we have all that. The bottom number should be 5, I believe. Let's see what the bottom number says. Yeah, 5. So everything's good to go here. In fact, let's do the second part first. Why not? Let's make our window. So there's that. Our window will go from our x min negative 4 to our max of 26. That was our range, or our domain, I should say. Our y min was negative 10. And our y max was 8. And let's see if I get a curve. That's a perfect curve. It should be a perfect positive sine curve. Again, we don't care about that value. Or did I already put the correct value in? I did. So that's 5. So I already have what I need. Now, notice how one of them is negative. That's okay. I don't mind that. I just want you to get the 2. So let's do that. Second trace 5. I hit up to get under the top line. I'm going to go all the way over here first. I hit enter, enter, enter. So I have negative 0.5158. So negative 0.5158 plus the period is 30, so 30k. No pi there. The pi is already included in everything. So x equals that. X can also equal this point over here. And obviously, guys, if you're really getting this, you can start fast forwarding through things and just checking your answers. Why don't you try it on your own? I just have to go through it. 7.5158 plus 30k. And finally, we can solve for f of 6.3. That's saying I know what x is. The other thing you could do is you could actually do a value on here if it's on your screen. But we know that it is because our range is from 0 to 26. You can hit second trace value, and I want to know the value when x is 6.3. Now it has to be showing up on your graph though, okay? And you get 6.4963. So 6.4963. Alright, so that's number 7. One more to go. We have a negative cosine curve. Again, I'm going to do the middle part first. Normally, cosine is from 0 to 2 pi. If I multiply everything by pi or 16 over pi to get rid of that, you get 0, x minus 1. 2 times 16 is 32, and the pi goes away. So this is the period for this one. Okay. The shift, though, goes 1 to 33, and then the node is at negative 4. So that we don't really need to put that in anywhere. So negative 4 plus 3, so we go from negative 1 is the max value, and negative 7 is the min. So I have all my information. Let's type it in. Negative 3 cosine. I'm going to just insert that. Negative 3 cosine, and it's pi over 16. And then it's x minus 1. And what was the last part? Minus 4. Okay, and let's go to our window. And, oh, hold on. Someone needs a report to the pool. So, alright, so we have our window is from negative 1 to negative 7. No, that's not our x min and max. It's 1 to 33. Our y min is negative 7. Our y max is negative 1. So this should be a perfect cosine curve, negative cosine curve. Oh, I didn't put the y in yet, but again, you should try to get one full perfect cycle on your calculator by using your information. And then I want to know when y is negative 2.5. So I'm going to change my y2 to negative 2.5. So again, when you have an x there, that means you're looking for x. That means you are putting it in for y. Alright, so there go the curves. And we can find our two intersection points, and then we're done. Oh, and then we have to find the value also, but that takes 2 seconds. Alright, 11.6667. So x is equal to 11.6667 plus the period is 32k. The other value you hit enter a couple times is 22.3333 plus 32k. And finally, 4.1, is that in our range right here? I believe 4.1 is in our range here, or our domain, I should say. So I'm going to just do second calc, or second trace, and then 1, and I want to find it at a value of 4.1. So when x is 4.1, you get negative 6.4612. Negative 6.4612. Okay, now again, that won't work if you're not in your window. If I said find when x is 56, you couldn't do that. Now let me show you what happens. So if I said find x when x is 56, you get an error because there's no 56 in here. Okay, but you can do 1 because we're in 1's okay. 1's in this range here. So that's why you can also use function notation on the home screen. All right. So let's find the. Where's the thing that I need? Well, I don't know. I'll figure out a way to turn this off in a second. Let's do the other things first. For some reason, the bar's gone. Let's talk about, so you guys are done if you understand this. If you want to see real quick how to do these again, find theta to the nearest minute. Now I'm going back to degrees because it said nearest minute. Remember, if you're in degrees when you're graphing, it won't work out real well. I need to find big arc sine of 0.9872. That's sine inverse. 0.9872. I'm in degree mode. There we go. And then second angle 4. So it would be 80 degrees, 49 minutes for that one. And since it's big arc, 80 degrees, 49 minutes, I believe it was. Yep. Since it's big arc, then you're done. Okay. Big tangent, same thing. Just type it in. Second tangent of 2.3456. And then you do second angle 4, and you get 66.55. Remember, 35 rounds up to 55. So 66.55. Theta equals 66 degrees, 55 minutes. Okay. Arc cosine. This is one. Now it's little arc, so we have to do the multiple values. Okay, so I'm going to do arc cosine of 0.4762. And I hit enter. And I do second angle and hit 4. And I get 61 degrees, 34 minutes. So theta is equal to 61 degrees, 34 minutes plus 360K. Now, if I look at that on a circle, 61's about there. It's positive x, so don't go over here automatically. We actually want to go down here. So that means I want the angle from there all the way there, which is basically 360 minus 6134. So I can do 360 minus my answer, and then you can convert that into degrees, minutes, seconds, and you get 298.26. So theta is equal to 298 degrees 20. No, that wasn't right. What was it? Yeah, it was 26. 26 minutes plus 360K. And that, and then we have tangent. Tangent's nice because even though it's little tangent, you still only need one solution because tangent repeats itself every 180 degrees. So I can just hit this, get the angle. You have to still remember to do the 360K though. So 44.29. So theta is equal to 44 degrees, 29 minutes plus 180K for tangent actually. So, and that's the answer. All right, so those are the answers. And that was a long video. Sorry about that, but you didn't have to watch all of this. And I will see you guys later.